Welcome to Zero Knowledge, a podcast where we talk about the latest in zero-knowledge research and the decentralized web. The show is hosted by me, Anna.
And me, Frederick.
This week, we catch up with Jordi Baylina, the co-founder of IDEN3 and the creator of Circom. We chat about his work in the ecosystem, building zero-knowledge circuits, and the new roll-up project Hermes. But before we start in, I want to say thank you to this week's sponsor, Parity Technologies. So Parity has been mentioned more than once on this show. Frederick is currently the CTO there, and once upon a time, I worked there too. In fact, it was during that time that the ZKPodcast, was born. So for this spot, the folks at Parity wanted to share that they are currently looking to fill a number of job positions, including many on the engineering side. As an engineer at Parity, you would get to write Rust all day, be at the forefront of creating and shaping the decentralized web, and hopefully also dig into some cool zero-knowledge crypto tech. The best way to get noticed for this role is to familiarize yourself with Substrate, the platform built by Parity, which makes building blockchains much, much easier. So go check out the Substrate libraries and then head over to parity.io/jobs to find out more. So thank you again, Parity, for sponsoring this episode. Now here is our interview with Jordi. Today we're going to be catching up with Jordi Baylina, who's the co-founder of IDEN3, the creator of Circom, Snark.js. Welcome to the show, Jordi.
Thank you very much, Anna. A pleasure to be here.
So Jordi, you've already spoken at the ZK Summit, and actually we'll add the link to that in the show notes where you do go into Circom in detail. But I'm so happy to have you actually join on the podcast. It's kind of crazy that this is the first time that we have you on, because I feel like I see you around a lot.
You've been at the events, been at all the conferences, and not only in our conferences, but obviously around the space for a really long time.
Yes, I'm in the space since 2015.
Oh, wow. So this is the thing I wanted to actually start in on, because I just realized last week, I was reading sort of this description of the DAO hack, and your name was in it. And I know that Griff must have mentioned this when we had him on the show, 2 years ago talking about it, but I don't know if I knew you then. And I didn't put it together until literally this week. So let's find out about kind of your beginnings in the space. You say 2015. Was it Ethereum? Was it Bitcoin? Where did you start?
Well, actually, in 2013, I read the Bitcoin paper. I get very excited about that, and I start. I was trying to do some smart contracts. That's actually the thing, and it was a pain.
On Bitcoin?
On Bitcoin, yeah. It was a pain. That was my beginning. I realized that most of the opcodes didn't work, and it was tough. At that time, I also had a lot of work in my old job. So a little bit I put it on the side. And in 2015, later on, just after a JavaScript conference, somebody started talking about decentralized storage. I discovered at that point IPFS. And well, at that point, that blew my mind. I start investigating. I don't know how I discovered Ethereum. And the moment that, I just took the smart contract that I was trying to do 2 years ago, and in 2 minutes I set up a Solidity code and upload, and it was working. And for me, then I was just catched by Ethereum.
You were hooked.
I'm absolutely hooked. Yeah, and at that point it was like obsession, just getting all my free time, my free time, my sleep time, all my time just reading, understanding, going deep, and so on. And there is at some point I get into the DAO project. Everybody was excited about that project, so I started reading the smart contract on that. I was even writing a liquid democracy for the DAO at that point.
Wow!
But just learning, just learning the code, and there is I get involved a lot in. At that point in there, you discover here it's not was about technical at this point. It even was all the social part of the crypto space. Mm-hmm. You discover that it's not only a technology. So it's when your mind starts blowing a lot, and there is when the hack happened. I knew a lot about the smart contract. People just asking me there, and I just get involved in the rescue the DAO. It was my baptism in the.
It was your baptism.
It was in the.
What's the expression of that? It's like baptism by fire.
I translate from some Catalan expression. So
no, but I think there is an expression in English
fire
called
is definitely a thing.
Yeah,
it was.
Sounds like that was very much.
It was a learning. It was a lot of learning. When I discovered how the hacker did it, I reproduced that in the testnet. I speak with Slovakian people and just send them the code, and they just told me that they were just working, that there was a people of white hats that they were already working on saving the funds. So I just joined a call in there. I was like the last guy arriving there. It was like a movie. It was crazy, I was in a call with a lot of people that I don't even know nobody there, and the people were moving $100 million just rescuing there, and I was just there in the call listening. I couldn't believe the level, and it was interesting because at the end of the call, they rescued 96 millions out of the 100 millions, but there was $4 million, and I had my chance there. Maybe I can try to use my smart contracts there to try to rescue, and I was able to actually recover that for the last $4 million, and from there my life just changed.
You just made this comment about how it was like a movie. And a few years ago, after we had done that interview with Griff, which, by the way, I'll add in the show notes for anyone who wants to hear that sort of extended story of the DAO hack, we had just done that interview. Frederick, I don't know if you were there that day. Yeah. Okay, so we all met up with someone, a friend of mine, who, he was not in crypto at all. And we were buzzing about this story, kind of looking back at it, but we were so excited about it. And we explained it to him. He's actually a filmmaker, and it was so fun to try to explain it to someone from the outside, but it really does have the drama of a movie.
Yeah, actually, I have a friend that I explain exactly like you explain. I explain him the story, and he likes to write books, and he took my story. Of course, he changed it. It's just a fiction story, but he took my story as a base for a novel for him, and he wrote a novel. Has nothing to do with
Ethereum.
It's Ethereum actually, but it's like he just mixed and just put more on his side, and then mix other stories. But it was like the base for his story. It's just it's a local writer, but I understand what you mean. It was very, very crazy, and for me it was very, very impact. I told you my life changed completely at that point.
I have a question actually about the DAO hack specifically that I guess I've never cared enough to investigate on my own, but I've had this question several times. What happened to the funds on ETC? So there was this split because things were recovered, and then ETC, it wasn't. What happened on ETC side?
The day of the ETC hard fork, we actually thought that the story was over, but then is when ETC appears. And we just start resynchronizing servers and so on. And we did there all the recovery. We did what we can. I think we missed some date time at the beginning, but there was a lot of DAOs. It was a very complex situation, but we recover 70% or 80% of the funds in ETC. And recovering that point, that was actually the most difficult part, because this was not a technical part. We had to return. So we recovered these funds. We returned them to their owners. But the story for returning was a hard one. We tried at first chance to convert them back to Ethereum. That's where we had all the tooling there. People knew that. So we tried to move them to Ethereum. But this was a mistake. We didn't realize that. But this was actually a mistake. So at the moment that we tried, because you need to try to convert that, but it was difficult because you need to do it in a way that's secret in order to try to maintain the maximum value of the tokens, but at the same time public, so that you can prove that actually you move the funds. And this was not. So we set up a full strategy to move at the same time and story. And I remember this was really bad because we just hit the button to move the funds, and I think it was Poloniex just block us the funds, and they told us oh, there is some funds, something like there was some funds and from suspicious places that has been moved. Everything is in hands of the FBI, and at that point, okay, so we just took all the remaining funds. We created all the smart contracts. We created a smart contract where the people could withdraw their funds, and then we just flip it back with that. We are ready to return the funds. Please, exchanges that you have blocked us, please send the funds to this smart contract so that the people can recover it back. Yeah, in less than 24 hours, they just send the money there. So, and the people just start withdrawing and everything is there.
Did the hacker get away with something?
Yes, I think he get at that point was something like $4 or $5 million or something like that.
In ETC, I guess.
In ETC, yes. Yeah, but then this is when the Ethereum was at 10 or something like that. So everything get crazy at that point. But that's what I told you. For me, that was my baptism. I learned here a lot about exchanges. I learned a lot about people in
those scenarios.
Yes, it was a huge learning for me. Just we learned about analyzing the blockchain, auditing, generating these smart contracts for returning security issues. I learned a lot. For me, it was a master class on all that. And yeah, so just
how do you go from that point to zero knowledge proof stuff? Like what we're talking about was in 2016, right?
Mm-hmm.
When and how did you first get interested in the zero knowledge proof side of things?
I could not say an exact date, but when you are in this space, at some point I decided that I want to be here just full time. It's like that. This is my life and I want to be here. And the first thing that you realize is that this technology do not scale. So if you want to use this technology in a real world, you need to think about scaling the blockchain. I get very obsessed on the scaling. I was studying just state channels, side chains, and different solutions that Plasma that was at that point. And I was very pessimistic on all these solutions until the point that in some way I connect the zero knowledge on all that stuff. I remember that Vitalik wrote an introduction to Zika Snarks, and I was reading there. I had to read like 10 times, those posts because they are not easy and there are some unconnected parts and you need to go to step. But at the moment that you get it, at the moment that you understand it, it's like you see how it's like this thing. No, it's not that hard, It's maybe it took you like a month just to understand it. But once you get it, you see that you appreciate the simplicity. You appreciate that. Well, it's not. It's really cool, And when you start seeing all the applications that it had with privacy, with a lot of applications, is when you get interested and when you really see that this is the future of this space, or at least an important piece in the future.
Yeah, it's interesting. So it's interesting that you came to it more through the scaling side. Like you must have been aware of like Zcash and these other projects out there, but for you, it only really landed in your lap as a solution to scaling. When or maybe like who first put those two ideas together?
I remember there was a post from Vitalik also talking about ZK rollups. Well, it was rollup, that this idea of separating the computation, the scaling of the computation side of the validation, so the validity part, and the scaling of the data availability, and splitting the problem in these two problems. This is what really blows your mind. This is actually the real piece of these blockchains can evolve. And then it's just a matter of doing numbers, just making numbers. How many transactions could you do? How much would cost to create the proofs? How you would set up that? And you start thinking and just analyzing the problem, and then you are learning and you are discovering. And yes, that's identity. This is when I start working with identity. That was this privacy part, but also this scalability part. In the identity system, we want to build a system that all the identities can do as many claims as they want. So it's not a centralized system. It's a sovereign, decentralized identity. So you need to scale. If you want to claim, that means you need to do this attestation, and you need to scale this quantity of attestations that the system can handle. And here is where comes again the solution of the Snarks, which is cool because it's the same technology that you can use it for privacy, but at the same time for scaling. an actually problem. This is, I hear from somebody that says that what really make the big interest of the Snarks is more in the scaling side, the privacy. Privacy, nobody cares about, about that, which is sad, but that's the truth. But in any case, it's an amazing technology.
We're sort of maybe related, and sort of a side question really is, were you involved in the Ethereum-based system that was set up in the Spanish political kind of nightmare that was going on for a while, where there was an identity system on Ethereum for voting, for tracking where these like political groups were meeting and all this stuff?
I'm a Catalan. I have nothing to do with Spain.
Okay. So were you part of the Catalan Ethereum project?
Yes, in the Catalan, I'm just working for Catalan to be an independent country, and I think that blockchain is an amazing technology that can help on that. Especially, the goal in my life is Catalonia be a liquid democracy system where Catalans decide their future. I want to retire when this happens.
Yeah. Did any of this work act as a precursor to IDEN 3, or was it completely separate, like separate trains of thought?
I told you, this is my long-term goal, if you want, my ideology goal. But in the middle, you need to create a self-sovereign identity. You need to scale blockchains. You need to work a lot in the technology. So at the end is this is the long-term path, but in the short term, you need to work in the everyday's project. And in the everyday's, here is where scaling, self-sovereign identity, and so on. And Catalonia is just maybe my motivation, but this is a technology that works for any community in the world that can really self-organize and self-govern and all that together. So yeah, that's really cool.
What is IDEN 3 then? So is this a company?
IDEN 3 is a protocol where everybody can create an identity, or if you want, a set of identities. So those identities can create claims, mainly on other identities, and then you can prove those identities to third party. So IDEN 3 at the end is a simple protocol where you can create identities, you can create claims, and you can prove those claims. And that's it. We want to try to keep it as simple as possible. This is the basic for any identity system. And the goal of IDEN 3 is to define a protocol that can be used in a decentralized manner for doing that. So it's a base layer protocol on that.
I'm curious what the claims can be. Like, can I claim that I'm a Swedish citizen, or that I have this education? Or...
Yeah, you can have this degree on this school. You can claim that I have a debt on something. You can claim that you are a nice person, and that your podcast looks so. It's really cool. A claim is any statement that you do. It's a notarize. It's like if you go to notarize, you write something and you put in a notary. So you can prove. Prove that later. So I'm doing a claim on you, and then for a typical example, I'm claiming on you, I'm the university, you are a student, I'm claiming to you that you have this degree, and then you can take this claim and prove to an employer that you had that degree. And all that with privacy. So if I'm the university, I don't even have to know that you are proving that to this job. So when you want to keep all this privacy in the full layer, and at the same time the scalability, here is where the challenge comes, and where the zero knowledge is a key piece. So we start doing this identity system, but then we realize that the zero knowledge are so important. So that's also why we developed all this tooling for zero knowledge. All this Circom and Snark.js comes mainly for this need. We need to build this protocol, so we need to define that. Of course, you learn a lot on that, and you are doing like iterations, and maybe you could do this way, you generate the proofs, the snarks this way, how you manage identities. It's complex, but it's simple.
So you've explained where the zero knowledge proofs fit in, but do you feel like the Circom and Snark.js, has that become like a bigger part of this project? Is that sort of your main focus nowadays, or is it like still within this umbrella of IDEN 3?
No, it's bigger than that. When you do this project, and when you see that many projects start using that, you need to understand that, and you are trying that these tools be not a tool only for you, it's a tool for the community. Here it's, I don't know, there is interesting projects. I know Tornado Cash is using that. We talk, so this game, you say what's the name? Dark Forest game is using that, and Semaphore is using that. So it's like a lot of projects that are using Circom. And I think that Circom brings this technology to a lot of new developers that discover the zero knowledge through these tools.
I think we haven't actually defined what Circom actually is. So what is it?
Circom means circuit compiler, so it's like it's not a
awesome.
Not a fancy name. But,
it sounds super cool, though.
Yeah, but Circom is it's at the end is a language to write programs that can be run in zero knowledge. So let me explain. So when zero knowledge, what you're doing is you're proving that you made a computation, but without you to have to repeat that computation. You can verify that much faster. But how do you program what computation you want to prove? In the case of the rollups, for example, this computation is about verifying all the transactions. So you verify that the signature is okay, that you have enough funds in your account, and all these typical validations. So all this process of validating that, at the end you want to summarize in a single proof that everybody can verify very fast that all this computation that can be long is proved really fast. So how do you write this process? So how do you write these programs? You cannot use regular languages. You need to write these programs in a very specific manner. So you have a lot of constraints that you need to use there. So Circom is a specific language that helps the developer to write those programs. Yeah, those circuits. We call it circuits programs.
Oh, okay.
It's very much the same, but we call it circuit because the properties of these programs are very much like an electronic circuit. Huh. So imagine an electronic circuit without latches, just ands and ors, and you just do any computation you want, but just ands ors, just you have an input, all of and of ors and all of the output. So you at the end you need to convert whatever you want to compute with ands and ors. If you want with a circuit, that's why we call it a circuit. And that's converting that is that, and it's a DSL language. It's writing Circom is very much like writing electronic hardware. You just do very small components, maybe an addition, a multiplication. You have a very, like transistors, in electronics, you have like a small components. With this, you do maybe gate components. And with these gate components, you do others, and then you do more complex operations, and you are building blocks, every time more complex blocks, and at the end, you build your program out of these blocks. This is how we call DSL. And at the end, it's just taking blocks, connecting them all together, and generating the circuit that you want to build. So Circom is a language to write that. It's very simple. It's very easy. We have good tutorials, and it's very easy to just step in and try.
When you first started on this, what was already available out there? Like, were there no languages that you could use? Like, why did you feel you had to develop a new one?
Mainly, at first, it was the Lib Snark, was the original.
But that was a library, though, right? Or
it's a library, yeah, yes. But for writing those languages, you need to understand a lot about C++, and was quite complex to program in that. At that point, there was Socrates. I started doing some work with Socrates, but I was very disappointed, especially because you couldn't, in Socrates at that point, I think, that they changed it and they moved forward on that. But at that point, it was very difficult to use all the tricks that these circuits can do. For example, for doing a division, you don't have an operation that's a division, you have a multiplication, but you have a constraint. So actually what you do is you calculate the multiplication and then you add a constraint that the result multiplied by time fits that. And then there is this kind of, a lot of these tricks that when you're writing circuits are very important, that it was not very well solved in the other languages at that point. So I just I wanted to write circuits, and the ones that were there didn't fit to me, and I just wrote my own languages, and it's very simple. It's really cool. People like it, and it's becoming very much a standard for writing circuits.
How did you approach writing your own language? I mean, you could have made an embedded DSL in something else, or did you just write a new compiler from scratch? And what did you write that compiler in?
Yeah, I brought a new compiler from scratch. Just there is a lexical part, and then just create the branch. And I'm not a compiler expert, but I knew some of the basic techniques of compilers, and like all the project, it starts a little bit like a toy, and it goes growing and so on. And right now, this language is fully rewritten. Right now, it's Rust, a rewriting of Circom in Rust that's done by people from university that knows much more about compilers than myself, and is doing a full rewriting of the Circom. It goes a little bit slowly, so because this had to be like 3-4 months ago, and it's still work in progress. But they are working hard, and I hope that at some point they will replace the actual JavaScript Circum that's right now what it is. But it will come whenever we find. While the current Circum works well, and it's fine.
I can imagine a lot of interesting challenges, though. I mean, especially on the optimization side, when you have these super complex circuits, there must be tons of optimizations that you can do to typically in a compiler, if you have this, you're building on building blocks, then you do things like inlining, and you kind of fold a bunch of these layers together at some point before you spit out the end result.
Yeah, there is a lot of things there to do. This is the idea is we are trying to keep it separated. So it's like the compiler just compute these intermediary signals, and it creates a constraint system that's maybe not optimal. And then you can have other intermediate stages where you can run all these optimizations. The problem of these optimizations is that they need to be audited very well, because you can mess it up easily. So
it might change the logic.
Yeah, exactly. So it's better to keep the compiler as simple as possible, and then all these optimizations, put them as plugins.
Yeah, like post-processing. Yeah.
At the end, or maybe even the different stages. So that's a little bit the strategy that we are following for that. But yeah, it's work in progress. All that stuff.
Does Circum work with every sort of ZK Snark scheme, or is there like a particular type of Snark that it's built for?
Circum actually it generates R1CS. It's a rank 1 constraint system. So it generates a constraint system, and it also generates the code to calculate all these intermediary variables that you need to build. When you want to create a proof of a specific program, you need to run that program. So you need to compute all these intermediary values, and this is important for that. So this Circum does these two things. Generates the R1CS system and generates the code that computes these winners. So all the cryptographic primitives that can take as an input on a R1CS system, it works. For example, here is bulletproofs can be connected to there. With some Aurora, it has some sort of, many of them, a lot of these constraints, a lot of these systems, they have this input. Plonk, for example, it's not, but it's very, very easy to adapt. It's not really an R1CS, because it can have only two. It's not a linear combination. It just have a very limited set of signals. But when you have a linear combination, convert that to many, just add them together. It's not difficult. So just connecting Circum to Plonk, I don't know. So this will be done it's in the to-do list. Maybe somebody's doing it, but it's in the to-do list, and it's not a difficult thing to do.
Do you feel like Circom is really the kind of the tool for certain kinds of constructions, and then others? Do you see any other languages kind of emerging to deal with some of these new schemes that are coming out, like Marlin, or like maybe the vanilla Plonk that doesn't use R1CS?
We'll see. This is, I think that it's very early. I see that in these circuits, in these languages, there is two sets of languages. One is more, if you want, more high-level languages that are more close to what would be a standard like Python or like Rust, more that looks more like a traditional language. And there is languages that are more low level. This DSL language is more like writing it's assembly. Just you put the things together. So, and the other side, these other circuits, probably in the long run, maybe will be less optimal. They would generate more constraints, and it would be less optimal, but it would be maybe enough. But in the long run, probably this would be more the future.
So like would they have to write their own high level in a way, or maybe even a library that interacts with Circom, but that's optimized for this particular thing?
Yes, it's exactly. It could be that way. We'll see how this ends up. But Circom is very good when you want to have full control exactly what you want to do. In Circom, you have full control of the constraints you are writing. And in Circom, for example, so there is no special library. All the components in Circom are written in Circom. There is nothing like special things that you need to import. And so in Circom, you can write any language you want in Circom itself. And this is in an easy way. So this is I think this is one of the coolest thing of Circom. And yes, probably on top of Circom, maybe there would appear other languages just for these more high level languages. But if you have the mind of an electrical engineer, Circom is really good, because it's just, you can do very, very, very complex circuits too, because at the end it's just a complex circuit is the union of many less complex circuits, and these less complex circuits are the union
of more less.
Less. So at the end is you can build the full thing, and the other cool thing of Circom is that you can, not fully, but you can audit, for example, a specific component, a specific subcomponent there, and you can be sure that at least this piece, you can treat it as a black box, and
it will work as it says.
Exactly.
Okay.
To see the
like
connections.
The electrical kind of engine.
Exactly. So if you have for electrical engineers, Circom is their tool.
Okay.
Are
you actually an electrical engineer by study?
I'm a developer, but my studies are, I'm a telecommunications engineer.
Oh, yes. Perfect. Makes sense then. You seem like the right person to be doing this.
And I've been designing electronics for a while.
Oh, cool. I wonder, how does Snark.js fit into this? What is Snark.js then? It's separate from Circom, right?
Yes, Circom just generates this R1CS, and Snark.js is a JavaScript library that actually implements the Zika Snark protocol. So it takes as an input this R1CS and this witness, and it has all the tooling for all the setups of the Zika Snarks, for generating the proof, for verifying the proof, for generating smart contracts that can be deployed and verified on chain. It's all this cryptographic implementation of the Zika Snark, concretely the Groth 16 protocol.
Okay, so the Snark.js will, how do I say this? It compiles into a Groth 16 curve. Like how would you say, what's the interaction?
So you write the Circom language, you compile it with Circom, so you have like two files. If you want the R1CS constraint system, it's just a file with all the constraints in there. And then you have this, in general, it can be WASM or C++, but imagine that's a WASM file that actually computes all these intermediary values. Okay, so this is the output of Circom. So Snark.js, what it does is, well, first of all, you need to run the trusted setup ceremony. So Snark.js first includes all the tooling for this trusted setup, includes all the powers of tau, which is not specific to any circuit, and generates all these powers of tau. And just, I am sure we
covered it on, we did an episode on the trusted setup, but yeah.
Just let me ask people, just please collaborate to the trusted setup ceremony. This is really...
the perpetual really powers of tau one, you mean?
Yes, exactly. Yeah. That's important on that. But that's, with Snark.js right now, it's like a second implementation of this multi-party ceremony. It's the independent implementation, which is important even for the same ceremony, because at the end you end up just trusting a simple software. Right now we have two different softwares that are doing exactly the same thing. So it's more difficult that there is some problem in the software.
Wait, where is this? This is in Snark.js, or this is like...
This is in Snark.js. This is Snark.js. So we have this powers of tau progression ceremony.
Yep.
then you take your specific circuit, you compute like the first key, but then you need to run this phase 2, this other
phase
ceremony
2 of this trusted setup. Yeah. Okay.
Yeah, so that you have also all the tooling for running for running your trusted setup ceremony on top of this circuit. Once you have this setup set, so you have like a proving key and a verification key. So with the proving key, you want to prove something, so you need to, you have an input to the circuit. You need to run the circuit with the WASM file that
you had back at the beginning.
The beginning. So you get all these, we call it the witness, but you get all these intermediary signals. Okay, and with these intermediary signals on the proving key, you just create the actual proof. Proof is it's a very short. It's like less than 1K, less than 1,000 bytes. It's like 200 bytes or 300 bytes of. That's actually the proof. And then once you have this proof, then you need to verify that. So you have to verify the verification. The verification, you put this proof. Maybe you have the public inputs or outputs, and with the proof and the public input or outputs, you can verify that actually you run the circuit in a way that this public input and outputs match. And with this proof, you can cryptographically verify that this was actually done that way. And then you can also, with Snark.js, you can take this verifier and upload it to the Ethereum blockchain. And you have all the tooling on that. And the cool thing also for Snark.js is that it fully works in the browser, which is really important. You can do all these ceremonies, and you can generate the proofs. You can verify the proof. You can do all the tools. It works in the browser. It's the full tool right now, and this is the last updates. It's fully written in WASM, so it's very optimal code. It's run also with workers in parallel. So it's, of course, it's not native host, the generation of the proof, but we are getting closer to there. Maybe it's like 2 times, 3 times, 4 times slower, but not 100 times slower. So and this is very important. If you want to have, for example, there is a project that's doing that, for example, for voting. The voting, you probably want to you want to generate that proof probably in the browser. So you need to run there. So this is the importance also for Snark.js, is that you can do that in the browser.
Does it work with anything other than Gross16?
Not currently.
Will it?
Yes, we will see. Actually, in my to-do list, I want to really get deep in Plonk at some point. But right now we are very busy with the Hermes launch. But I hope that after the Hermes launch, we can have some time to get deeper in the Plonk and all these new versions, all these new turbo Plonks and all these new add-ons based on Plonk that are very, very exciting and very interesting. And I think that their Snark.js and Circom can be used for those new schemas.
Yeah.
And maybe someone that already has not been invented yet.
I think that it's a fair trade-off. I mean, if you talk about people who actually want to build applications with Snarks, most of them are still extremely skeptical to using anything other than Groth16 because basically nothing else has been used in production, like for real. With real value attached. And it's questionable. Like we've had many conversations with cryptographers on this podcast who go like, yeah, if it was invented in the last 10 years, you probably shouldn't use it. And yeah, it's like, I don't know. I think it's a fair trade-off to say it supports Groth16 and then like once something else is really proven, you can start building out support for that. But I mean, it's also like Snark.js is, as I understand it now, like a complete toolkit for someone who wants to build an application using Snarks, right? So it's the whole stack, including like deploying a verifier to a chain. And so you want that reliability there. You're targeting someone else than a researcher, basically.
Yeah, this is when you want to create a project that for real, a project that will hold, we expect millions of dollars there. You need to consider very much these decisions. You know that you need to assume some risks. You need to understand exactly what risk are you assuming, and you need to cut at some point. Here, for example, in Hermes, we decided to launch with Zika Snarks. This is a known technology. There's still a lot of things. I would say that the point that we are risking more, and here is where, at least if you want, is our point that we are moving forward, is mainly Poseidon. Poseidon is a hash function inside the Snarks. This is a less used. It's not used in Zcash. They are using Pedersen hash. Here we are betting Poseidon. I know that there is other projects that are using this already in production, but here is probably the most risky primitive that we are incorporating. Yes, that's we assume that we know that, but at some point somebody needs to. I would say that every project needs to include something there. So we believe that Poseidon is very new, but we have a strong confidence that this is going to be a good hash function. And maybe we are wrong, and you never know, right? But I think it's we can assume that, and that's it's a bet. But yes, what's the most critical from the at least from the cryptographic perspective? What's the most critical part of Hermes project? Was Poseidon hash. That's what gets me more scared.
Let's actually introduce this project you've mentioned now, Hermes. Hermes rollup. What is this project exactly?
Hermes is a rollup, very much as standard ZK rollup, as we understand. And the main differences here is that we want to, Hermes, we designed it with decentralization in mind. Also, the other thing that we are including is all this proof of donation. We understand that we are running on top of a layer one. So we have, in some way, we need to promote, we need to help, we need to just put the word you want there, but we need to grow together with the layer one. So this is the proof of donation. The idea of this proof of donation, that's like 40% of all the transactions fees that will be collected from the Hermes will go to the layer one, the community, to the community funds.
Where are you collecting this from? Maybe you can walk us through where that collection point happens.
Yeah, this is how it works. The idea is so here is who can be an operator. The operator in the rollup is the one that just collects the transactions, embed them in a batch, and then send a transaction in layer one, including all these transactions in a single layer one transaction. That's the compression that's in the rollup. So here the idea is how do you select who can be the coordinator? Okay. So this coordinator, one option could be just to centralize. There is a centralized coordinator, and that's it. That's the easy part. And here we are betting for a more decentralized system. And here the idea is that everybody can be a coordinator. The idea is that we divide the time in 10 minutes slots, and then you bid to buy this slot. So I want to buy this slot, and then it's an auction. The one that bids.
I bid to be a coordinator during those 10 minutes.
Exactly.
Okay.
Exactly. And the winner, the one that's willing to bid, that's willing to spend more money, this is the one that really gets the chance. And during these 10 minutes, you can forge as many batches as you can. So if you have a good hardware, and if you have you can collect a lot of transactions, then looking for you send transactions, but you will have to pay your cost. So you cannot put like a high value there because it needs to compensate for you. It's an auction in there. So from this money that we collect from this auction, it's 40% is burned, 40% goes to the community, to this community fund in some way. We will start using this. We don't want to get very much distracted on that. So with this, we will probably at the beginning we'll use this quadratic funding on Bitcoin, but at the end it will be we will not even decide that. So probably we'll send it maybe to the Ethereum Foundation, and Ethereum Foundation will send it here. So it's just it will go to the layer one. So we this is something that's community funds. We should not be able to decide
how they get spent.
How they get, they need to get for the layer one. So that's the
and then what's the last 20%? Where does that go?
20% goes to the investors. It's going to be a kind of a token that the people that has this token then will get this reward.
What's the point of burning tokens?
Yeah, the idea of burning is that if you send it to somebody else, then you can cycle the money. It's like I'm betting for something, but I can bet a lot of money because at the end, the recipient of this money is myself. So it's like, and then you always win. So the idea is that you need to be a huge amount of this percentage that's burned. Actually, this is like 40% is burned directly, and 40% more is in some way we don't control that. It just goes to the community. Yeah. So this 80% should be more than enough.
Well, why not send all 80% to the community?
Well, that would be another option, but we also are the problem of sending to the community. We are also afraid that there may be some feedbacks. It could be some corrupt in some way. So I think that having 40% that's burned for sure. This creates. Well, we know that at least 40%. So you are going to lose a lot, and then we have like 40% that if everything works okay, it's like an 80% of burn if you want. Okay,
yeah.
So that's a little bit. This is a
hand wavy.
Yeah, it's a little bit but I think that are good starting points, and well, at least we want to maintain that and see how it works. That's
the individual or this bid, this auction at the beginning. There's this person or this entity who's trying to get to be the coordinator on the batches. Is that what you called it, a coordinator? I'm forgetting now.
Yes, coordinator. Yeah, sometimes operator, but it's better. Coordinator is a good name. Yeah.
Okay, coordinator or operator on the batches. They're paying, but what do they get? Like, why would they do this?
Well, they get all the fees. They get all the fees of the transaction. So when you are sending a transaction, there is a fee. So they are collecting all the fees of all the transactions they are including in all the batches that they are generating.
I see. And you know that that's going to be enough that it matches their...
Well, this is what coordinators needs to in some way optimize and bet. If there is a lot of transactions with high transaction fees, then they will be able to bet more or maybe they have a good cost. They have a good systems that they can run it very cheaply and they can generate the proof very fast, and they have these competitive advantages with the other coordinators. This is actually their margin. So this is where they can bet on that.
I just realized something that maybe I'm not fully clear on with the roll-up concept, but is there actually gas on the transactions within the roll-up? Because that seems...
It is. It's a transaction fee, very much like...
It's a newly, but it's not related to the actual mainnet transaction fee in any way.
It's not related directly, but at the end...
There is a fee to write to chain.
Well, so at the end, the coordinator needs to create a transaction on the mainnet, and he needs to pay for the fee for the gas in the mainnet. So in some way, they need to... Yeah, well, you need to include this. They need to include this cost in the people's transaction.
Got it.
The thing is that the cost of these roll-up transactions is gonna be like much lower. Maybe, I don't know, 50 times less. Or,
yeah. But you still so it's like the overall mainnet transaction fee will be smaller because it's batched.
Exactly.
And that has to be included in the transaction fees in the roll-up. But you still get a much discounted transaction fee.
Exactly, but this is important because people think that the roll-up transactions are free, and
aka me just now.
It's not, okay? They are not really free. So it's like, I can promote them, okay? I can make you a gift, and it's going to be free for you. But actually, somebody needs to pay the gas of the proof, and here is where Zk Snarks are unbeatable. Zk Snarks are unbeatable in the verification cost and in the proof size. And these parameters is very important, especially with these high gas fees in the Ethereum. So that's why Zk Snarks is still the best schema, zero knowledge schema. If you just take in account this parameter, the cost of the verification on chain, it's like twice, it's like half cheaper than, for example, a Plonk, or I don't know, many times cheaper than Starks or any other schema on there. So Zk Snarks is still a good. Maybe it's not like the last trending in the zero knowledge space. It's like every Halo and Plonk, and it's like appearing a lot of new things which are cool, and I tell you, it's like we need to get in there. It's not. I'm not going to say. I don't want to say that they have very good properties. They don't need this trusted setup. Some of them you can use some more normal cryptography inside the circuits. So there is a lot of advantages of these. They have recursion. They have a lot of advantages on these new schemas, and I don't want to say that they are bad. But for the specific parameter of the verification cost on chain, Zk Snarks are still the best.
And you mean the ZK Snark with the trusted setup, and so that's the big disadvantage.
Zk Snark Groth 16
with the trusted setup,
with the trusted setup, yes.
That's an inherent nature of the of that structure and of the cryptography, but also because Ethereum doesn't support any of the other cryptography. So, I mean, if you wanted to deploy something else and there wasn't, an EIP for it first, then it would be 1,000 times more expensive because it doesn't support the crypto.
I would say yes and no. So first, there are some other, for example, Plonk, it's supported if you are using the BN 128 Corp. So it's supported by Ethereum, but even just forget about Ethereum. Just see the cost,
and just
the
inherently
verification
in the math.
And the size of the proof. You just how many bytes the sites have. I don't care. Just forget about the cost of the blockchain. Yeah. How big is the proof and how much just takes a regular CPU to verify your proof.
I have a follow-up question on the fees because, well, I wonder how are the fees on the operator side calculated? Because as you said, the operator has to pay something, which makes me think that they will have to be able to set some minimum fee at least, or maybe decide the fee entirely. But then you don't have the same fee structure as on Ethereum where the user can, kind of bid with their fee, right? Like if I pay more, maybe I get included. So how are the fees actually decided?
Yeah, the fees are decided very much like any other blockchain. So at the end is the operator can select the transactions they want and they just include them in the batches if they are reliable. But because this gas cost and because this variable cost, it's going to be for sure a minimum fee there. But here is something very specific for the coordinators, and the coordinators probably will have to distinguish two situations. One is when they are running at full capacity, and the other is when they are running under the capacity. For under the capacity, this is going to be probably easy. It's going to be just a minimum fee that will be set by the coordinator. And in full capacity, it's going to be very much what we know now in Ethereum or Bitcoin. This is
like an auction.
An auction. And you just, depending on the moment of the day, you will have to pay a little bit more or less, yes.
But there's a difficult problem where if the operator says, okay, I'm going to pay 10 in fee, 10 something. And so they said, I'm predicting that I'm going to get 10 transactions. So I'm going to charge each transaction a minimum fee of 1. But then they only get 5 transactions. Do they still submit the block kind of on time, quote unquote, on time? Or do they hold off until they get 10? Or, it feels like a hard trade-off for the operator.
There is an optimization problem there. That's one of the things that we are working there. And this is one of the nicest models of Hermes that we are building. But this optimization problem, and let me add you on top of that, this is with, we are doing that with millions of transactions. We are scaling. So the difficulty there is that's not have 100 transactions there. We have maybe, 1 million transactions, and we need to select which are the right ones and make these kind of decisions. Once you earn the auction, then this is like a sunk cost. So at the end is as far as you need to understand very much what's your variable cost of the fees, and at the end it's just it's a decision problem. It's like how much transactions, what are the best transactions that I can get, how much I get on that, and is it profitable for me? So generating this transaction, or maybe I need to wipe. Maybe you need to wipe, or if it's enough, then you just send it there. And it's an optimization, and this is one of the difficulties and one of the nice things that needs to be coded in the coordinator side. Right, in coordinator, it's as I told you, it's interesting engineering problem.
It might also be a little bit like just we have to accept it as a variance problem, that it's a repeated game we have to play, and kind of like mining, you're mining and most of the time you're not winning, and that's just on cost and you're losing. But then every once in a while you win and you get enough to recoup the losses.
Yes, this is something that maybe the technical people is not very used to, but if you talk with business people, this is actually what they are doing all the time. At the end, it's managing the risks and evaluating the risk and decision making, and this is something that's very studied in the operations. If you talk any operation manager of any big company, that's mainly what they are facing all day. It's an unknown problem for many of the devs that they don't know this subject, but it's a known problem in the industry, in the other industries, in the production industry and other manufacturing industries.
We actually are almost at time, but we're close to the end of our questions too, so we're on track. I wanted to ask, is Hermes a concept or is it a full-fledged product? Like, would somebody come along and build with Hermes or on top of Hermes using Hermes as like a structure, or is it going to be a DEX of itself?
No. Hermes is going to be a public rollup. It's a Hermes that everybody can use. Everybody can use to make payments on top of that. It's not going to be a DEX, but it can be DEX that can be built on top of that.
But you guys aren't building that.
We are not building. The cool thing of one of the interesting properties of Hermes is that they will include atomic transactions, and atomic transactions, for swapping one token to another token. And this is it's an important piece for any DEX that wants to be built on top of that. But it's just a primitive that Hermes will include.
How does Hermes really stack up against the other rollups that already exist? So there's like Loopring has come out, and there are these sort of off-chain layer twos like Diversify that also, are using Snarks and bringing like some of these transaction data back on chain. How does it distinguish itself?
Well, there are different projects, and each one has his ways to understand the technology, and I would say even many other ways. For example, if you compare with Loopring, that, by the way, it's an incredible project, and it's a project to mirror on. It's a very
like an inspiration.
Yeah. So it's a very good project on that. So it's for example, Loopring is more a DEX itself, and it's more the concept of the centralized coordinator, which for the kind of project they are building it's okay. But for example, we are trying to build a more decentralized coordinator system. Here we include this proof of donation stuff that I think this is something that's new and needs to be tested, and this can be used in other rollups, for example, in maybe some optimistic rollups or some ways to select the coordinator. So that's a cool idea. It's an idea that comes from Barry Whitehat, and I think that's something that can add a lot of value to the space. Also, this proof of donation that you are giving back to the community, to the layer one. I hope that other projects in layer one follow this. Layer one two just follow this schema to maintain or to help improve the layer one. I think this is important for the space that this happen, and also the strategy for promoting, for launching. We are also building wallets. We are building APIs. So at the end is we're building a project there.
What you just said there, though, that idea of like contributing back to layer one, I feel like, 2 years ago, I did not think we'd be in the position where there's so much value on layer two that you actually have to think about maintenance of layer one. But I guess that's what's happening, right?
I tell you, my point, I think that at some point, everything, all the value is going to be in layer two, and layer one is going to be just, layer two. Now these transactions of coordinators on that. This is like extreme, and it's going to be a process, but layer one that do not scale, and it's going to be very expensive. So when we go to mainstream, we will need this layer two, and layer one is going to be just for these highly valuable transactions that at the end are going to be the layer two, the transactions that come from layer two, and I do not have a crystal ball, but I think that the space goes in that direction.
But what about if ETH2 comes out, though, what happens? Like, as I understood it, rollups will probably still exist on shards when ETH2 comes out. Like, it's still going to be relevant, but like, isn't it supposed to solve some of the things that layer 2 solves for?
For me, rollup is very much what in Ethereum 2 is called an execution environment.
Okay.
At least a rollup is a kind of execution environment. So the way I see it, and maybe I'm not the right person, I'm not an expert in Ethereum 2, but how I see it is that Ethereum 2 will be mainly data availability. So you want to do a transaction, so you will publish this data in some shard somewhere, And then you will get this data and will include in some execution environment, rollup, if you want to call it rollup, that will be managed and then in some chain. So it will be, this state will be updated. So you will update some state according to this. So this is how I see that how the scaling will work. You need data availability. That's why we need all the sharding and stuff. And then you need these execution environments if you want rollups that can execute thousands of transactions. It's just thousands of transactions, but with a very small cost for the consensus environment. And there is where also gets importance this inter rollup communication or interlayer 2 communications. That's all these Ethereum 2 they are having already start thinking about. Sometimes they mix it with this inter-shard communication, but it's like for me it's inter-execution environment communication and value transfer. Yeah. That's why this needs to be evolved and think very much on that. But that's how I think that the space will evolve and how will scale.
Would you say is Circom, I'm going to kind of go back to what we talked about earlier in the episode with Circom specifically, but do you feel like Circom is in the Ethereum toolkit or could it be used by many different things? It's pretty broad, right? It's not written in Solidity or anything.
Circom is for writing circuits, and you can use the circuits wherever for anything.
I shouldn't have said writing written in Solidity because I know it's a language, but I'm more like it's not deeply connected to Ethereum tooling.
No, the only connection point is mainly that I'm an Ethereum community member. So for me, it's like I'm thinking with Ethereum in mind. That's a very weak connection. Yeah. And the other thing is that
are you seeing it being used in other places?
Yes. Circum is used in many projects, and a lot of projects. For example, maybe they end up using Snarks or something else, but there is a lot of developers. Just Circum, just by the fact that's introducing so many developers to the zero knowledge space. It's so important for just for that. Okay, so that's at least for that is there is enough value in Circum just with that, and of course Circum is much more on that. You can really build real and for example, Hermes. One of the goals of Hermes is we are using Circum for developing all these rollup, all the rollup circuits are going to be written in Circum, and this is also it's an important milestone for Circum because.
An entire roll-up built on it. But did Loopring not use Circom?
No, Loopring, I think they know Circom. They start building something on Circom, but they are using, as far as I know, they're using Snarks.
Okay, got it.
As far as I know, but at least this part I think is not open source, so you should ask them.
Actually, that leads me to who are the people building Circom and Hermes? What is this how many contributors do you consider kind of part of your team?
Let's see. Circom is we have some collaborators, but Circom is very much myself. Okay. It's just Circom and Snark.js. I would say that I'm 90% of the code is written by myself.
Okay.
The other thing is Hermes. Hermes mainly it's the full Aiden 3, the full Aiden 3 team. Yes, we frozen a little bit the identity and we focus. So we are about 20 persons developers working there and we are at this moment we are full steam preparing Hermes. We already have a couple of 2 proof of concepts in testnets and so on. We are just adapting, doing some changes and rewriting, refactoring some models. And right now we are full steam. Most of the team just working on that, and that's exciting. But right now it's we are in launch mode. We are just going for steam.
So the last question I have that I didn't get to touch on: what is the proof? Where is the proof of donation, and what is that actually?
Well, it's a way, instead of saying proof of burn, it sounds really bad. It's at the end, it's you are actually in order to select an operator, you need to prove that you actually made a donation.
I see. So it's like proof of stake, where you stake money, but here it's proof of payment.
Exactly. It's proof of donation. It's you are proving that you made a donation, in this case through an action. But you are a coordinator if you prove that you make this specific donation. That's where the name comes from.
So does proof of donation is there like any consensus principle to it, or is it just a proof as in like a hash or something?
Consensus in this layer 2, it's the consensus protocol. Everything happens in layer 1. Yeah, that's the thing. And proof, yes, because there is a transaction that you can prove that with that transaction. Yes.
Okay.
So we're at time, and it's unfortunately time to wrap up and end this in some way. It's been fascinating talking about what has been done, but we usually end on this this question of looking forward. What are you looking forward to, and what's exciting to you at the moment?
Well, right now, as I told you, I'm very, very focused in launching Hermes. I hope that in the next quadrimester, this will be launched. But if you go a little bit further, and for me, there are a lot of interesting things that will happen. One of the things that I'm very, very interested in, it's something that's very excited, is for example, all these massive migrations. That means that the end is transferring, it's massive transfers between one layer 2 solution to another layer 2 solution. This is something that we start talking about and start being a debate that it is between roll-ups communications. That's really important side. Of course, there is Ethereum 2.0. That's very important, especially for the data availability side. It's going a little slow, but I am very excited because I hope that Ethereum 2.0 will solve this data availability, and this will increase a lot of the scalability and so on. Then there is all these recursive snarks where you can start, there is some projects that already have started working on that you can have privacy inside the rollup or even smart contracts inside the rollup. That's very exciting. Then there is all the identity that's still there. We hope that at some point we can have a full compliance rollup, just linking that with all the identity. We want to continue, and it's a project we are continuing there. Right now we are focused on Hermes, but identity is still there. Right now my goal is Hermes, but the identity is a really important project for the space, and we have the commitment to continue working on that. Well, yeah, just all these new protocols that are appearing like every week, and new projects, super exciting projects. I don't know, last week there was like a couple of projects that were very, very interesting and promising. Coda and it was again Pickles. That was very interesting. All these recursive, just to verify the full chain. That I think that's a very, very cool project too. And there is a lot of new projects in the space that are happening, and at the end is my goal is that all this happens. So
you're on your way then.
Yeah, exactly.
Cool. Well, thank you so much for coming on the show, Jordi.
Thank you to you.
Finally. I can't believe it took us so long.
Whenever you want, Anna, I'm open. Just let me know.
Cool.
Thank you very much. Yeah.
Thank you, Fred.
And to our listeners, thanks for listening.
Thanks for listening.